welcome to the third video in our multi-part video series all about lithium batteries and how they pertain to the RV lifestyle. I've got David Bayliss from BM Pro and Ryan Hammond from lithium specialist Sentry. So we've heard all the stories, guys, about lithiums in phones and airplanes causing fires. So what's different here when it comes to the lithium batteries for RVs?
Okay, so I think in one of the first or earlier sessions we spoke about the differences in lithium chemistries, and there are different types of chemistries and each has their different characteristics. We utilise lithium iron phosphate due to its their safety characteristics. Now, when compared to other lithium chemistries, there's a couple of things which are different. One, it's got a very high thermal runaway point. So whereas the thermal runaway temperature of a lithium iron phosphate is up around the 250 to 270 degree mark, some of the other chemistries will hit that point at about 130 degrees as well.
So when you're referring to, so to bring it back to electronics, when you're talking about thermal runaway, you're talking about the ability for it to be able to, have a fire or to be able to melt down. Basically, the components and the electronics in there are totally safe up to those much higher temperatures as what you get with some of the other lithium polymers.
Correct. Yep. Yeah. So there's the other benefit of lithium iron phosphate is that the oxygen atom is very tightly bonded, which means even under extreme abuse, it doesn't release any oxygen, which means there's nothing to burn.
Yeah.
Okay. So having said all of that, we also have a safety mechanism in there, which is sometimes called a BMS, battery monitoring system or management system, or a PCB, protection circuit board. And that's critical for the safety of the batteries to protect the cells against things like overcharge, over discharge, short circuit, over temperature. So as well as having the lithium iron phosphate as being the most safe lithium technology, we also have the built-in protection in the form of a BMS or PCB.
So there are different types of cells inside some lithium batteries. What are they, Ryan, and why are they better?
Yeah. Okay, so there's three main types of cells that are used in sort of silicate acid replacement style lithium iron phosphate batteries. Probably one of the most popular is the cylindrical cell, which is like your 18650, similar to your AA or A size. And they're quite low in capacity, so it might be 1.5 amps or 3 amps, which means in order to get a 100 amp hour battery system, you need 4 in series and then a whole lot of them in parallel. So that means you've got a whole lot of cells in there. They're very popular in electric vehicle battery systems, and they're quite low cost to manufacture. But having a lot of cells in there means that it does introduce some inefficiencies within the batteries.
1 or 2 cells go down and you've got the battery.
Correct, yep. And it does mean that there is sometimes more complexity in the battery monitoring system as well. So that's the one, the cylindrical cell. The other one that we see quite often is a pouch cell, and it's very similar to probably what you'd see in a mobile phone. It's a soft pouch, okay, and they can expand and contract as they're being charged and discharged. We actually utilise those in our starter batteries. Sometimes they have a high discharge rate, but they're more susceptible to heat and humidity. Then the third one is a prismatic cell, which is what we use in the BM Pro Sentry, and we've got an aluminium case, so they're very robust. They don't expand or retract with charging or discharging as much, and they're designed for deep cycle applications. So specifically designed for deep cycle applications. Large capacity as well. We've got 20 amp hour, 25 amp hour. You can get even up to 100 amp hour cells into 3.2 volts, which means you've got less cells in your battery pack, which is greater efficiency and less complexity in the battery itself.
So, Ryan, you mentioned the internal battery management system. How is that actually working to protect the battery? Or, I mean, David, you might be one to cover this.
So inside the top of the battery, if you were to pop the lid on this, which I think we've done in a previous series, when you pop the lid, you're going to see a small PCB in there, probably about 100 mil by 100 mil.
A printed circuit board.
A printed circuit board, correct. And across that, there's going to be a range of electronics in there. Some things we use for communications and various different things, but the main purpose in there is to be able to balance the cells. So it'll control the amount of, unlike say a lead acid battery where it's just what I would call dumb inside and it's relying upon that chemical reaction. In here, we're relying upon the printed circuit board and the electronics and the design in that BMS as we call it, to be able to deliver the right amount of current and the right amount of voltage to each of the individual cells and keep them working in unison in there.
And do lithium batteries have an emergency vent like you might find on an AGM or gel battery? And what should a customer or an RVer do if they saw that the lithium battery had vented?
Yeah, they won't vent.
They won't vent?
They don't have venting. Yeah, so there's nothing really there.
Nothing to worry about in terms of, okay.
Look,
right.
I'll just add a little bit to the PCB as well. It's there to also protect the cells within the battery. So against abuse. So the abuse could be someone puts in a too high voltage across the terminals, in which what it does then is it opens the switch and goes into open circuit and prevents any damage to the cells. And that happens if you do an over voltage, if you've got a short circuit, if you overcharge the battery, or if you over discharge the battery, or if the temperature gets too high. So under all of these conditions, the PCB will essentially go into an open circuit and protect the battery. It means you won't have power, but it does everything's safe.
Yep. Good. And as for the operating temperature of a lithium battery, can you expect the same performance as you might get from a lead acid battery?
Well, I think temperature affects lead acid batteries probably in a similar way. It degrades and reduces the life of the battery. With ours, lithium iron phosphate, it's up to 65 degrees is the rated usable, both charge and discharge.
So that's the safe operating temperature?
Yep, both charge and discharge. Yes. Okay, some will give you a high temperature on a discharge compared to a charge, and those temperatures are different. But essentially what will happen is once it gets above that 65 degrees, then the BMS will protect and it'll go into open circuit. Okay, so it's not unsafe above that temperature, but you won't have you can't charge it or discharge it because it goes into open circuit. Once the temperature of the cells, and this is the cell temperature, mind you, not ambient, once it gets below 55 degrees, then it'll go into you can use it again. Now, that parameters are different across different brands, but ours are 65 degrees.
So I'd imagine all batteries have to meet fairly stringent safety requirements. Do the cells get certified, or is it the battery as a whole?
Yeah,
it can be done two ways, can't it?
It can, yeah. And look, that's an interesting topic here in Australia because there's no enforced requirement really. So most reputable dealers will have a cell certification on either the IEC or a UL equivalent, and that's normally the IEC is the 62133, and that's an IEC testing on the cell level, and then they obviously build it up in the cells. And as I said, most reputable manufacturers will have that certification at a cell level only. We have it at a cell level as well. The Pro has it at a cell level as well. Century have taken the next step, and we've actually had the complete battery system certified. So this includes the testing of not just the cell, but all of the cells together, all wired up. So it takes into account cell-to-cell short circuit, for example, which just a cell by itself wouldn't. Also takes into account the BMS parameters and ensures the testing of the BMS as well as the complete battery system. So although there's no requirement, and again the main difference is that some have it at a cell level only, whereas we've got it at a cell level but as well as a complete battery level system.
And I mean, that's what we're selling at the end of the day. That's what we're putting out there with the customers. So that's what we feel at BM Pro from we're really big onto the compliance and the certification of those types of things. So having a complete unit, if we're going to be supplying people with this complete battery as such, we want the entire thing certified, not just individual
Yes.
componentry on the inside.
Yep. And I'd imagine here at BM Pro, David, you guys have, extensively tested these batteries. What have you experienced?
Yeah, look, we have extensively tested them. We've got a large test unit out the back which really thumps the batteries. We've tested a range of batteries against these, a range of lithium batteries against them, and then also a range of lead acid batteries against them as well for a comparative. And these batteries, which is one of the reasons why we've partnered with Sentry, is that they perform and they react extremely well with the charging algorithms and the electronics which we've created with the BM Pro range of chargers. So the battery management systems, the power management systems we have with the J35 series or the BP35 series, as well as our standalone AC to DC chargers, are perfectly designed and they just match beautifully with these, and that's how we've done our testing between the two.
Thanks, David. I think that's really fascinating. And make sure you tune in next month when we're going to talk about the dollars when it comes to RVs and do they stack up on a price basis.